Good morning, students. Today, the lecture title is Disaster Risk and Climate Change. We are going to start a new module today, week 8. Mitigation and adaptation is the central concept for this particular week. And we'll be discussing disaster risk and climate change, who are the drivers, and then we will check the mitigation and adaptation, transformative solutions, where we will discuss a lot about the nature-based solutions, and NBS for climate adaptation and urban resilience, that will be discussed later. Ecosystem-based adaptation and EcoDRR will follow. So today we will be discussing disaster risk and the climate change. And in that, we will be discussing the definitions, the evolution of the concept, the components, and the characteristics. So let us see how the lecture can unfold. What is disaster? UNDRR, if you remember, United Nations Disaster Risk Reduction, that platform, intergovernmental platform that defines a serious disruption of functioning of a community or a society at any scale due to hazardous events interacting with conditions of exposure, vulnerability, and capacity, leading to one or more of the followings, like human, material, economic, and environmental losses and impacts. So that's the way disaster is defined. So what is this? Based on this definition, we can again discuss the disaster as an event, a serious disruption. The focus is whether the community or a society is getting impacted or affected. What is the source? Hazardous events. Interacting with conditions of exposure, vulnerability, and capacity are the determinants for this disaster. What is the outcome? The losses and impacts to human, property, economic, and environmental conditions. So, now let us proceed for disaster risk. So, UNDRR again we are depending on. Disaster risk is the potential for loss of life, injury, or damage to assets that could occur to a community over a specific time period. And this disaster risk indicates where, why, and when potential loss can occur. If you look at this particular image, you can see that disaster risk is getting contribution from the components like hazard, vulnerability, and exposure. And we will look at these three components in details later on. So, disaster risk concept has evolved through ages, and very recently we can see the scientific documentation of this particular concept. In 1990s, according to UNDRR, disaster risk is the potential loss of life, injury, or destroyed or damaged assets which could occur to a system, society, or a community in a specific time period, determined probabilistically as a function of hazard, exposure, and vulnerability. In the technical sense, it is defined through the combination of three terms: hazard, exposure, and vulnerability. In 2009, the progress we find that according to the International Organization of Standardization, the risk could be defined as combination of the probability of an event and its consequences. So, risk is the probability that an accidental phenomenon produces in a given point of fx of a given potential gravity during one given period. So, these are the probabilistic part. So, risk is the probability of an event and its consequences. It came from the ISO. UNISDR in 2009 Executive Committee, they had discussed about risk again, and then they said risk is defined as the probability of harmful consequences or expected losses like deaths, injuries, property loss, livelihood loss, economic activity disrupted, or environmental damages. All these resulting from interaction between natural or human induced hazards and vulnerable conditions. So now in 2011, the risk concept is having probability of losses, and again which are hazard, vulnerability and elements at risk, function of all these three components. Now we can see in the meantime there are a lot of interest from the science group, and many scientific peer groups have worked on it, so that professionally also they can keep on working on this. Not only the concept, they can also go forward to disaster risk reduction and management. One such initiative is INFORM. The INFORM risk concept considers Cardona. Cardona is the main scientist who brought this particular concept of INFORM on the risk indicators, holistic risk assessment, and vulnerability frameworks. These three form a foundation for the INFORM. The aspects of physical exposure and physical vulnerability are integrated in the hazard and exposure dimension, and the aspect of weakness of the socioeconomic system becomes informs vulnerability dimension, while lack of resilience to cope and recover is treated under the lack of coping capacity dimension. So these are the three dimensions they have worked with. In 2015, further progress we can find UNISDR Global Assessment Report is informing us that disaster risk is expressed as the likelihood of loss of life, injury, and destruction, and damage from a disaster in a given period of time. It is widely recognized as the consequence of interaction between a hazard and the characteristics that make people and places vulnerable and exposed. So, again, we are coming back to that initial concept, hazard, exposure, and vulnerability. According to Professor Kaoru Takara in Asia Pacific Association of Hydrology and Water Resource APHW 2019 conference, he said disaster risk is actually a function of hazard, its magnitude, frequency, severity, exposure, population, assets, landscape, vulnerability, age, gender, health, knowledge, awareness, preparedness, and inversely proportional with the countermeasures like infrastructure, early warning systems, hazard risk maps, etc. So, if you look at this disaster risk concept together, you will find that risk is having three dimensions: hazard and exposure, vulnerability, lack of coping capacity. Categories in the hazard and exposure, natural and human; in the vulnerability, socioeconomic vulnerable groups; and the lack of coping capacity, institutional and infrastructure. Then the component wise, you can read this image, and this is also from the UNDRR, so you can read it and you can understand whatever we have discussed, how differently it has come. Like under the vulnerability, development and deprivation is having very important role, and then the inequality and the economic dependency. So likewise, under each one of them we can find that, like in the coping capacity, governance, disaster risk reduction, preparedness responses, they become important components. I think in today's time, all of us we know we don't discuss hazards only as natural. Hazard, natural and human, man-made, both we are discussing, and you can find that in the first column. Hazard is the first component which we are going to discuss under the disaster risk. Hazard is a process or phenomena or human activity that may cause loss of life or injury or other health impacts. It may also cause property damage, social and economic disruption, or environmental degradation. Hazards may be natural, anthropogenic, or socio-natural in origin, which I was discussing just now. Hazards are often categorized by whether they are natural or technological. The term peril is sometimes used instead of hazard, particularly in the insurance industry. Natural events are only termed hazards when they have the potential to harm people or cause property damage or social or economic disruption. The location of natural hazards primarily depends on the natural processes, including the movement of tectonic plates, the influence of weather systems, and the existence of waterways and slopes. But processes such as urbanization, environmental degradation, and climate change, they can also influence the location, occurrence, and intensity of natural hazards. These processes are known as risk driver. Types of hazard. Only in this year, UNDRR has revised the list of 281 hazards and they have grouped it in 8 different hazard types: hydrological and meteorological, extraterrestrial, geological, environmental, chemical, biological, technical, and societal. And you can see on this right hand side image that all these 8 groups are being presented. Each one are having some clusters and the number of hazards. Like let's see this technological 6 clusters and 50 hazards. Like that you can find several different hazards under the clusters which comes under these 8 major hazard types. These types of hazards, now we will be discussing them very briefly one by one. Hydromet, the first one, originating from atmospheric and water cycle processes. This affect weather and water system, causing damage through extreme weathers or hydrological events. So it can be convective related, particle related, wind and pressure related, precipitation related, temperature related, water, marine, terrestrial. So these are the subtypes under the hydromet. Extraterrestrial 10 hazards under 2 clusters. Hazards from sources outside Earth's atmosphere with potential impacts on Earth's environment and human technology. So those 2 clusters are space weather and extraterrestrial. Next one is geological, which is having 4 different clusters. Earth-based hazards caused by tectonic and geomorphological processes that lead to ground movement, eruption, and landscape changes. Subtypes of seismic, volcanic, ground failure, and other hazards. Environmental 24 hazards resulting from degradation or alteration of natural ecosystems and environmental quality, and thus they affect biodiversity and ecosystem services. Subtypes are environmental degradation and forestry. Biological hazards, hazards from biological agents that can cause the disease, infestation, or ecological disruptions affecting human, animal, or plant. Subtypes are having infectious disease, specific infectious disease of public health concern like corona, animal infectious disease, insect related disease, plant related disease, and the biological hazards. Next, we will come to chemical one. These hazards are caused by the release and presence of harmful chemical substances, often linked to industrial activities and chemical accidents. Subtypes are heavy metals, trace elements, carcinogens, toxic gases, and so on. Technological, 50 such hazards are there. These hazards are stemming from technological or industrial failures, infrastructure breakdown, or accidental release with direct or cascading impacts. There are again several subtypes. Societal, 9 hazards. These are arising from human socio-political processes that disrupt social order, safety, and livelihoods. Subtypes are conflict, post-conflict, behavioral, economic. So after these 8 different types of hazards we have understood, which is actually bringing almost all the hazards possible in the world together, we will try to understand the hazard topology from the interaction spaces, like triggering relation, cascading hazards. One hazard can trigger the other one or series of others, and that's the way it forms a cascade or domino event. Like storm can trigger landslides and floods. There can be another relation like amplification. What is this interaction? One hazard changing the landscape and thereby increasing the probability of other hazards occurring. Like, let us take an example of sustained heavy rain, which will increase the likelihood of flood. Then the third one is the compound hazard. In this particular interaction, we can see that hazards may coincide in space and or time with impacts greater than the sum of the two. So for the same place, two different type of hazards may happen in two different times, or maybe two different hazards are happening in the same time. Primary hazard triggering multiple secondary hazards within a given time frame, or coincidence of two independent hazards, or hazards occur consecutively with one hazard changing the vulnerability so as to make exposed assets more susceptible to the impacts of the following hazard. And we have seen n number of examples of all three. Now we'll be discussing vulnerability. Vulnerability is the characteristics and it is determined by the physical, social, economic and environmental factors or processes. This increase the susceptibility of an individual or community, and we are discussing the characteristic of this individual or community actually. Their assets or systems to the impacts of hazards, that is the vulnerability. And this accounts for the susceptibility to damage of the assets exposed to the forces generated by the hazard. Let us see what type of problems may occur. Like fragility and vulnerability functions, they estimate the damage ratio and consequent losses, or the social cost like number of injured, homeless and killed generated by a hazard according to a specified exposure. So that's the way we can also estimate that vulnerability. It is also defined as predisposition to suffer damage due to disaster risk, the likelihood that some places or groups will be less able than others to navigate the recovery process successfully. So that is also another way of defining vulnerability. The vulnerability can be of again different types. First one is the physical vulnerability, potential for physical impact on the built environment and population. The degree of loss to a given element at risk. The degree of loss to a given element at risk or set of elements at risk resulting from the occurrences of a natural phenomena of a given magnitude and expressed on a scale from 0 to 1. So that's the way this physical vulnerability can be mapped. This is analyzed per group of constructions. Like I take masonry structure. Within that I try to check the vulnerability, or I check the RCC construction. So then we try to check their damage performances. It is intrinsic quality of a structure and it doesn't depend on location. Environmental vulnerability, the potential for physical impact of events on the environment. Then the social vulnerability, potential for physical impact of events on groups such as the poor, single parent households, pregnant or lactating women, the handicapped, children and elderly. Consider public awareness of risk. This vulnerability considers public awareness of risk, ability of groups to self-cope with catastrophes, and status of institutional structures designed to help them cope this. And the last one is the economic vulnerability, the potential for physical impact of hazards on economic assets and processes like business interruption, secondary effects such as increased poverty and job loss, vulnerability of different economic sectors. So these are the four different types of vulnerability. Now we will move towards the exposure. This is the situation of people, infra, housing, production capacities and other tangible human assets which are located in hazard-prone zones. Exposure is one of the defining components of disaster risk. If a hazard occurs in an area of no exposure, then there is no risk. The extent to which exposed people or economic assets are actually at risk is generally determined by how vulnerable they are, as it is possible to be exposed but not vulnerable. I will also give several examples towards it. Right now, one third of the people in the world are exposed to earthquakes, but 414 million live near one of the 220 most dangerous volcanoes. So that's the way they are exposed to the hazards. What is coping capacity? The next thing we will be discussing. It is the combination of all the strengths, attributes, resources available within an organization, community, or society. The fourth and final component we'll be discussing is the coping capacity. Coping capacity is the combination of all the strengths, attributes, and resources available within an organization, community, or society. For what? To manage and reduce disaster risk and strengthen resilience. What are the examples of coping capacities? Infrastructure, good infrastructure, early warning systems, hazard risk maps, flood insurance coverage, disaster aid experiences. These capacity helps to cope and which requires continuing awareness, resources and good management, both in normal time as well as during the disaster or adverse conditions. So again we are coming back to that risk equals to hazard, function of hazard, exposure and vulnerability. But as I said, the coping capacity is also part of definition of risk in from several scientist corner. Now let us understand further that hazards are not the risk. Let's say you have the intense widespread flooding, but you don't have any construction, any people. So the risk is zero. Moderate flooding, no construction, no people, then also it's a zero because hazard is there. Localized flooding, no construction, no people, then the risk is zero. So even if hazard is present, but there is no construction or assets or people, it is not risk. Similarly, let us see the H, E, V and C, how they interact and generate risk. In the same condition, intense widespread flooding, planned construction and good institutional support. Then the risk is low, moderate hazard and moderate exposure and high capacity, which makes the risk low. Whereas the flooding is moderate, but the area has unplanned construction, dense population, and no institutional support, so risk will be high. Localized flooding, no construction, no people, as we discussed earlier also, it is risk is zero. So it depends on the functions of H, E, V and C, which will generate the risk. Now we will be discussing very quickly the characteristics of disaster risk. Disaster risk is dynamic. It changes and we can make it increased or decreased depending on our ability to reduce the vulnerability, improving the coping capacity, etc. etc. It's a forward looking, something you can do. Right now, you can assess, you can plan, you can make decisions. That's the character of a disaster risk. It's invisible, it is compromised of not only the threat of high impact events, but also frequent low impact events that are often hidden. Unevenly distributed around the earth, hazards affects different areas, but the pattern of disaster risk reflects the social construction of exposure and vulnerability in different countries matter for risk. This is an emergent and complex process. Many processes, including climate change and globalized economic development, they are creating new and interconnected risks. So these are some of the characteristics of disaster risk. This is the disaster management cycle. You have the event, then it is the response, reconstruction, rehab happens, and then we go for the prevention, mitigation, preparedness. And we are prepared, and then once it happens, we are better prepared for the response and recovery for the next cycle. So, what is prevention? That is the measure which helps us to avoid the occurrence of disaster. Mitigation helps us at reducing that impact. Preparedness, state of readiness. This may be short term, which enables the stakeholders to mobilize, organize, and provide relief. Response, it is during or just immediately after that event has happened. Recovery, these actions are taken by the community and all the government and the non-government agencies to reset the condition after the disaster and minimize the vulnerability of the same kind of disaster in future. So these are the 5 phases of the DM cycle. Now we'll be discussing the climate change. By now, I think you have heard us in discussing that climate change is one of the risk driver. Climate change refers to a change in the climate that persists for decades or longer, arising from either natural causes or human activity. It is already modifying the frequency and intensity of many weather related hazards, as well as steadily increasing the vulnerability and eroding the resilience of exposed populations that depend on arable land, access to water, and stable mean temperatures and rainfall. Our glaciers are melting, our sea levels are rising, all are having very strong connect with this climate change. Now let us see from this image how this climate change is acting as a driver. Climate change is having the natural variability as well as anthropogenic factors, and that is impacting the weather and climate events. And we see the vulnerability and exposure and these events are making this disaster risk. Again, the another driver in this particular flow we can find from the development, which is bringing also the disaster risk management as well as the climate change adaptation. So, it's also trying to be attenuated. So, the climate change can also lead to changes in geographic distribution of weather related hazards, which may lead to new patterns of risk. It can increase disaster risk in a variety of ways by altering the frequency and intensity of hazard events, affecting vulnerability to hazards and changing exposure patterns. And with that, the other driver, if the development is being added, we can see it's going to make it more complex. So there is a very nice image from IPCC. We can see that hazards, how these different hazards are creating potential impacts, and these impacts are coming to the risk. And on the other side, we can find the exposures which are also linked with the risk and the vulnerability. All together is bringing the final result, that is the risk. So you can read this particular image figure carefully and you can understand a very good example of climate change, especially how it is bringing risk to the farmers and agricultural sector as well as in urban areas. These are the references. Thank you.